Hey kiddos, we are going to be discussing triangle mid-segment theorem today. So let's get started. All right, so first, what is a mid-segment? Okay, a mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. So for example here, I can see that M is the midpoint of line segment AB. And I can see that P is the midpoint of line segment BC. And I can tell that because of these markings here of congruency. Okay. So therefore, since MP is connected, this line here is going to be considered a mid-segment. All right. So the mid-segments of this triangle ABC in black at the right are MP, MN, and NP. Now notice a triangle always has three midsegments, and those three midsegments end up creating, what do you know, a triangle themselves, known as the midsegment triangle. So our midsegment triangle is MNP here. So now to get to the fun stuff, the theorem itself. Triangle midsegment theorem states that the I can't even read. The segment connecting the midpoints of two sides of a triangle is parallel to the third side, and here's a real important piece, is half as long as that side that it's parallel to. Okay, so DE is the mid segment, and remember, we know this for sure because of these markings right here. We know that E is the midpoint of BC because these two smaller segments are marked as congruent. We know that D is the midsegment of AB because of these markings of congruency as well. So that makes DE then a midsegment of this triangle, which then means, if we're going off of our theorem here, that DE has to be parallel to the side AC. And not only that, but DE is half of the distance of AC. So if I were to tell you that AC is 20, then you would conclude that DE is half of that, which would make it 10. So, first example, a walking path BD in a park intersects the sides of the park at their midpoints. So we should make some markings here. You walk from park corner A to the walking path BD, over the path to the other side of the park, up to the corner E, and then back down to your starting point. So let us draw our path. We start at A, and we go to path BD. We take it across. We go back down to corner E, and then we go back to where we started. How many yards did you walk? Show all your work. All right, so a few pieces of information that we need to figure out here. First, we know that this is a mid-segment because it has split EC into two congruent pieces, and it has split AC into two congruent pieces. So, therefore, a few things that we can figure out. We can figure out or conclude that AB has to be 90 because BC is 90. Now, to figure out what ED is, because we don't need the whole thing as they give us here, we know that these two pieces are congruent. So logically, that would mean that we would just have to divide 216 by 2. So 216 divided by 2 leaves us with ED being 108. Now, we have to figure out what AE is. So right now we have three pieces of information. We have 90, which is AB, plus we do have the mid-segment here, which was 68, that was given to us, which is BD. We just figured out that DE is 108, and we just have one more piece of information to find, and that would be EA. So remember that DB, being the mid segment here, is equal to half of the line that it's parallel to, which is EA. So we know that DB is 68 equals 1/2 of EA. So if we were to work this out, we would get, that's right, you said it, 136. You can always check that. Half of 136, or 136 divided by 2 should give you, cha-ching, 68. So now if we add up all of those, what is it, yards? Yes, yards. We would get 90 plus the 68 plus 108 plus the 136 would mean that we walked a total distance of 402 yards at this park. Example 2. Triangles are used for strength in roof trusses. In the diagram, we have UV and VW. So notice UV I did in blue, VW is in red, and they are midsegments of triangle RST. Okay, find UV and RS. All right, so notice I went ahead and identified that VW is here in red, and the line segment that it is parallel to in the triangle RST is RS. So what's important for us to remember is that the midsegment is half of the side that it is parallel to, right? So in other words, in this case, VW is equal to half of RS. Well, what do you know? We actually know what VW is, and that's 57. So 57 is equal to 1/2 of RS. So really all we have to do is multiply by 2, and we get rid of that. So that times 2, 57 times 2 gives us a total of 114 is going to be what line segment RS is. Do they tell us feet or anything? Inches. Sorry, inches. Okay, now let's find the other one. UV, which is in blue, okay, is here, and that's the midsegment. And they've given us, notice the side that it's parallel to in this triangle, RST is RT. And that whole thing is 90. And again, we know that UV is going to be equal to half of RT. All right, so let's fill in what we know. We don't know what UV is. It is half of RT, which is 90. So if we take 90 and we multiply it by 1/2, or basically divide it by 2, we can conclude that UV then is 45 inches. Example 3. Oh, this is the most delicious sounding area ever. Pear Street intersects Cherry Street and Peach Street at their very important midpoints. So should be making some markings here. Cha-ching. All right. Your home is at point P. Here is point P. You leave your home and jog down Cherry Street. Jogging, dot, 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 to Plum Street. Plum Street, over Plum Street to P Street. So dot, 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 dot. Then we go up Peach Street to Pear Street, over Pear Street to Cherry Street, and then back home. All right, so I tried to outline our path here. So we did a little double dipping in this area. Okay. Question is about how many miles do you jog? Okay. So I'm going to yo this problem for you guys. So on your own, make sure you do recall that these parts right here are congruent. Okay. And make sure that you're giving me the information based on the distance that we actually jog. So it's the path in red here. That is the distance that you're looking for in miles. Y'all got this.